I received a lot of questions about number 2 on the 2010 midterm, so we're going to work that one out in this video. So you have 5 eggs. Let's get that back. 5 eggs, right? And 2 of them are raw, and 3 of them are cooked. So now you go ahead and you pick 2 eggs, right? Your roommate picks them later, but we don't care about that because part A is probability that you pick 1 raw egg. So, well, what has to happen then? We have to either pick a raw and then a cooked, or a cooked and then a raw. So that is just equal to the probability of a raw followed by a cooked plus the probability of a cooked one followed by a raw one. Why did I add this? Well, because these 2 events are mutually exclusive, right? Mutually exclusive. Right? Because you can't pick a cooked and a raw one and a raw and a cooked one. If this happens, you know this cannot happen. So now let's work out these probabilities. The probability of picking a raw one and then a cooked one by the multiplication rule is the probability that we first pick a raw one, then that we pick a cooked one, given that we picked a raw one. Well, this guy is just 2/5. There's 2 raw ones and 3 cooked ones. So that, and the next one, if we've picked a raw one, then we have a 3/4 chance of picking a cooked one because we've removed one of these guys, and there's 1 raw left and 3 cooked left. So that's this times 3/4. So this is equal to divide by 2, so it's 3/10. And then we can work out what's the probability that you pick a cooked one followed by a raw one. Well, that's the probability that you first pick a cooked one, right? Multiplication rule again, times the probability that you pick a raw one given that you already picked a cooked one. So this over here is going to be 3/5, right? Since you can either pick a raw or a cooked. And there's 3 cooked, so that's 3/5. And if you've picked a cooked one, then there's a half probability, right? Because this guy is gone, that you pick the raw one, because there's 2 and 2. So this is now a half. And this is also 3/10. So 3/10 plus 3/10 is 6/10, which is 3/5. So that probability is 3/5. That's part A. Part B asks us, so you have events. This is B now. Events. You pick 2 eggs. You pick 2 raw eggs. You pick 2 raw. And the other event is roommate picks 2 raw. Roommate picks 2 raw eggs. Are they independent? Independent? No, they are not. Right? Why are they not? Why not? Well, if you pick 2 raw eggs, then there are none left for your roommate to pick. And if someone tells you after the fact that your roommate picked 2 raw ones, you know you cannot have picked them. They are in fact mutually exclusive. Mutually exclusive. And if events are mutually exclusive, they cannot be independent, because mutually exclusive means they can't both happen. So that means if I know that one of them happened, I know the other one didn't happen. And independence means that, well, independence not freedom independence, but independence in the probabilistic sense means that the probability of A given B is just the probability of A, right? This just means I know nothing additional about A by knowing B. So just by the fact that they're mutually exclusive, I know they're not independent. Now, part C. This is the part that I think we got the most questions about. C. I want to know the probability you pick 2 raw eggs or roommate, just call R, picks 2 raw eggs. So we know, first of all, from the previous part that these are mutually exclusive. So this, I can decompose it. I can just write it as a sum now, right? In mutually exclusive events, I can write them as a sum. If it's not mutually exclusive, I can't write it as a sum. You pick 2 raw plus probability that your roommate picks 2 raw. Now in the solutions key they say, well, this guy is the same as this guy. Yes, that's true. But I'm going to do it a different way. But I'll explain why it's true first. This is the same as the problem with the queen. What is the probability that the second card of that you draw from a deck is a queen if you don't look at the first one? This guy, it says, if you don't look then at what I drew first, then the probability that the roommate picks them is the same. But let's do it a different way. So this certainly is easy. So let's work out the probability that you pick 2 raw. This part's the easy part. Well, that's just equal to the probability that I pick a raw on the first one. So that's just probability of raw. And so that's the probability that I pick a raw. Multiplication rule again, remember, times the probability that I pick a raw given that I already picked a raw. Well, this is 2/5, and this is 1/4. So that's 1/10. Right, this is 1/4 because I removed 1 and there's 4 left. Now to compute the probability that your roommate is the one who picks 2 raw eggs, well, we look at probability that your roommate picks 2 raw eggs. 2 raw. Well, what do we know? This can only happen if I pick 2 cooked ones. So this guy in here, I have to have picked 2 cooked ones first. So really, what I'm actually looking at is the probability of the event where I pick 2 cooked followed by 2 raw. So that's just the probability of cooked, raw, right? Because I picked these 2 first. This is what has to happen. This is the only sequence of picks where that's possible. So that's equal to 3/5, then there's 2/4, right? Because there's 2 cooked out of 4 left. So now at this point, there's 2 raw out of 3, and now there's 1 raw out of 2. And if we carry through this multiplication, we also get 1/10. But that's one way of looking at it. But since this problem seems to be somewhat troublesome, let's look at it in a different way. We know that the probability that the roommate picks 2 raw given you pick 2 cooked is equal to the probability that the roommate picks 2 raw ones. 2 raw. Because in this is this it's this times the probability that you pick 2 cooked, right? Because this guy is probability roommate picks 2 raw and you pick 2 cooked. You pick cooked, 2 cooked. That's not so great, right? And you pick 2 cooked, right? Sorry, I want to go back for a second and just redo this part. I don't think it was really clear, so I'll just erase and I'll start again. The multiplication, let's start from the multiplication rule, right? The multiplication rule tells us that the probability that the roommate picks 2 raw given you pick 2 cooked, times the probability you pick 2 cooked, let's call them cooked, is equal to probability roommate 2 raw and you 2 cooked. Right? But we know that this is the same as the probability that the roommate picks 2 raw. Since the roommate picks 2 raw and you pick 1 cooked, the probability of that is 0. The roommate picks 2 raw and you pick no cooked ones, or sorry, and you pick 2 cooked ones, the probability of that is also 0. So the only way this can happen is if this also happens. So we can write it this way. Well, in this scenario then, the count of the box containing the eggs is now reduced to raw, cooked. And then, well, this guy, the probability is then he picks a raw and a raw, so it's 2/3 times a half. And then you multiply that times the probability that you pick 2 cooked eggs, which is times 3/5 times a half, and then we get the exact same stuff that we had above, and that's also a 10th. So that's 2 different ways of thinking about this problem. And now, finally, we can move on to part D, which is what is the chance that you and your roommate both pick 1 raw egg. So the probability you pick exactly 1 raw egg, 1 raw, and roommate picks exactly 1 raw, 1 raw. So note that this is an AND, so again, we will go ahead and use the multiplication rule. So it's the probability that you 1 raw, let's call it a 1 raw, times the probability that your roommate picks 1 raw, given you pick 1 raw. So this probability, right, this is just, you can do cooked raw or raw cooked. We did that before. So this guy becomes either probability of raw cooked, probability of cooked raw. So that comes together. And so we have 2/5, 1/4, no, sorry, 2/5, 3/4, plus 3/5 times 2/4, and that gives us 3/5, and then the probability of this next guy, well, so there we're actually drawing from a box of raw, cooked, right, because you picked the raw, and so this is what's left. So now that probability, this probability is probability of raw cooked given you picked, well, let's not even bother with that. In this world, so I've made this scenario blue, where this box only has 3 things, and the probability of cooked raw. So here it's equal to 1/3, well, times just 1, right, because it must pick a cooked on the next one, plus 2/3 times 1/2. So this is equal to 1/3. So then what we're left with is 1/3 times 3/5 equals, oops, that should be 2/3, sorry, because I added up 1/3 and 1/3 plus 1/3. So that's 2/3. So it's 2/3 plus 3/5, and that is now 2/5, which is the answer that we got.